Now we're going to talk about the z-score. The z-score is a measure of relative standing. And a z-score is the number of standard deviations that a given value is above or below the mean. All right, so in order to calculate a z-score, this is what we're going to do. So to calculate the z-score, the first thing is we're going to find out how far the data value deviates from the mean. So basically we're going to be looking for the deviation, which is x minus x bar. So the first thing we have to do is find the actual deviation. And then we want to standardize that by dividing it by the sample standard deviation so that we can answer the question how many standard deviations this particular deviation is above or below the mean. So the last step is to divide by S. Now this is in the case that we are dealing with a sample. So this is for a sample. Now we could also be dealing with a population, and in the case where we're dealing with a population, we calculate the z-score in the same way, but we use different symbols. So the z-score for a population is calculated this way. The z-score for a population, we're still going to take the initial or the data value and subtract away the mean to find the actual deviation. We're still going to find the deviation, but in this case, the deviation is from mu and not x bar. So the mean in this case is going to be represented by mu, and the standard deviation is not going to be represented by s, but by the population standard deviation, which is sigma. All right. So these are the formulas that we're going to use to calculate the z-score. So let's go ahead and do that with a data set. All right. So what I have is I have uh, these data sets which are basically point totals for LeBron James and Kevin Durant in January of 2013. The scale that I have here shows that z-scores from 2 to -2, basically z-scores that are in this range here, from -2 to +2, are what we consider to be ordinary values. So any z-score between -2 and +2, we consider to be that data value to be ordinary. If the z-score is larger than 2, then we consider those to be unusually large values. And if the z-score is smaller than -2, we consider those to be unusually small values. So what I want to do is I want to take a few data points from these data sets and see if they're unusual or not. So let's start with LeBron James. LeBron James, if you notice here, the highest point output for LeBron James in the month of January is 39 points, this data point right here. I'm going to go ahead and I'm going to calculate the z-score for that data point. So I'm going to take, I'm going to first calculate the deviation of that data value from the mean, how far it is from the mean, by taking 39, which is the actual data value, and subtracting from it LeBron James's average for that month, which is 27 x bar, and I'm going to divide it by the standard deviation of his point outputs for that month, which is 6.6. All right. And what this is going to give me is going to give me his z-score for that particular data value of 39. So let's see, we have 39 minus 27, and we're going to divide that answer by 6.6, and we get that the z-score for that data value is 1.82. You should always round your z-scores to 2 decimal places, okay? So based on this scale that I have above here, 1.82 falls somewhere in here. 1.82, it's, oops, 1.82, it's the ordinary value. So it's not unusual for LeBron James to score 39 points in that month. It wasn't an unusual situation. Let's go ahead and do the same thing for Kevin Durant. So let's see here. Let's get rid of this one for LeBron. Let's do the same for Kevin Durant. So for Kevin Durant, what I'm going to do is I'm going to look at his highest output for points in the month of January, 52 points. And I'm going to see how unusual or ordinary, that is. So let's see. Z-score is going to be, first we're going to calculate the deviation, which is going to be 52 minus his average for that month, which is 31.6. And then we're going to divide that answer for the deviation by his standard deviation, which is 8.4. And let's see what we get there. We have 52. We're subtracting 31.6. And we're going to divide that answer by 8.4. And we get that the z-score for this data value is 2.43. So 2.43 would be up here somewhere, 2.43, and that indeed is an unusual value based on the z-score. So that night was an exceptional night for Kevin Durant. All right, now let's look at the other side. Let's look at the lowest scores and try to find z-scores for them to see if they were unusual or not. So let's see here. We're going to get rid of this one. And now, let's see, for LeBron James, it seems like in the month of January, his lowest point output was 15 points. So we have 15 points here. And let's see where that ranks as far as z-scores is concerned. How many standard deviations that is away from the mean. So we're first going to calculate the deviation for that. So we're going to take the score itself, which is 15. We're going to subtract LeBron James's average, which is 27. That's his average for the month of January. And we're going to divide that by his standard deviation of points for that month, which is 6.6. Let's see what that gives us. We have the 15 minus 27, which is a negative number. Z-scores that are negative symbolize that that data value is actually below the mean. And we divide that by 6.6. And we get negative 1.82. That's interesting. It's symmetric. So negative 1.82 is back here somewhere. Negative 1.82 as a z-score. Falls in the ordinary values range. So it wouldn't be unusual for LeBron James to score 15 points. It wasn't an unusual event. All right. Now let's see how it works out for Kevin Durant. Let's find his lowest point output for that month. And let's see, the lowest point value I see here, oh, he had a very good month. The lowest point value I see here is 20. So let's see, let's calculate the z-score for that point output. We'll have the z-score. First we'll calculate the deviation. And the deviation is going to be, let's see, we have the 20. And we're subtracting from that his average, which is 31.6. And then we're going to divide that by his standard deviation for that month, which is 8.4. Let's see what we get here. 20 minus 31.6, so it's negative 11.6. And then we divide that answer by 8.4. And we get negative 1.38, which also falls in the ordinary values range. So it wouldn't be extraordinary or unusual for Kevin Durant to score only 20 points on any given night in the month of January in the year of 2013. So that's how we're going to use this z-score to determine whether a point value is very far from the average or is close to the average. And this number two standard deviations either above or below the mean, is what we're going to use as a cutoff point for values that we consider ordinary and values that we consider extraordinary. So in the future, we're going to look at a z-score of 2 or a z-score of negative 2 to be a separation point between values that are ordinary or usual and values that are unusual. Anything greater than 2 is unusually large. Anything less than negative 2 is unusually small.